All right, so now this is working, but it almost looks like Tron with the different grid elements, mainly because they're in a uniform grid, which is very undesirable. We want kind of a random element to it. So what we're actually going to do is, since these are equally one apart, what I'm actually going to do is just add random.value to both the x and the y, which will essentially give it an extra 1 to its position randomly between 0 and 1, which will vary it considerably. But we also don't want this many particles. This is a whole lot of particles to have. So I'm actually going to make another float, which is the chance of particle. And we're going to make this, let's say, 30%. 0.3 basically means it's 30%. Need the F since it's a float. And what we're going to do here is overall, if random is less than chance of particle, then we're going to do it. Otherwise, we won't. So this means that it'll go through this loop the same number of times, but the chance of it of appearing is only going to be 30%, and it's going to give it a bit of a variation in there so that it doesn't look so grid-like. So we're going to see how that looks. Okay, that looks a lot better. So we have a nice distribution up and down, but it is still on the uh, the two planes, like positive and -3, which works, but I think it would look a lot better if we spread it out a bit between the two. So what I'm actually going to do is switch it up so that it randomly chooses between that range, between -3 and +3, to give it a bit better variation in how it looks. So the way we're going to do that is we're going to change this out a bit. We're going to set it as a customizable element, public float min depth, and we'll call this -3. And we're also going to do max depth of just 3. And then when we come down to the code where, let's see, particle depth, instead of just having it these two, positive or -3, we're actually going to change this. We don't need this anymore, the half chance. What we're going to do is just spread it out. So this is going to be random.value. So this will be a value between 0 and 1. And then we're going to multiply it by the max depth minus the min depth. So what this is going to do is it's going to give us a value between 0 and 6. Since we're multiplying a value of 0 to 1 uh, by the max range, which is 6, we'll get a value anywhere between 0 and 6, and it can have fractions and everything. But what we want it to do is between negative and +3. So what we're going to do is add the min depth again um, to make sure that it gets offset down into the negatives. So if it was, let's say, +6, it'll go to +3. If it was just 0, it'll go down to -3. So it gives us that proper range. So now this will just go in there as it is. So we'll see how that looks. And it should give us a much better looking spread. Yeah, they seem to be parallaxing at all sorts of different looks. So that's okay. And if you look on the side here, you can see they're also spread out all over the place, which is nice. So that looks really good. The last thing I think I'm going to do is make it so that we have a bit of a different color variation. That would be interesting as well. So what I'm going to do is, let's see, we got to first do a color chance. So chance of color equals 0.1. So we're only going to make it 1% chance that there's going to be a color inside here. So if random.value is going to be less than or equal to the chance of the color, so essentially only if it's 1%, then we're going to do this. In this scenario, we're going to do the emit parms dot start color equal to new color. So we're going to do new color. We need 3 values, so we're going to do random. Color also needs a 0 to 1 range, so we're just going to do random.value. It works out. Random.value and random.value. And then 1f, because this is the transparency. We want it fully transparent always. So that's going to give us a random 1% chance that it's going to go through there. So just one second here, we'll test that out. Okay, so you can see that there are a few that have different colors here, which gives it a bit more variety. Wherever we move, we can see that there is movement even if we're away from the blocks. We can help tell if we're slowing down or speeding up and braking and stuff like that. One other thing we could do, one last thing that we'll do before we wrap it up is to do a bit of a variation on the particle size as well. So I think that'll be interesting because they're all the same size, which is a little inconsistent. So with the variety of nature. So what we'll do is do a public float again. And this time we're going to do min part size. And we'll do that as 0.1f. And then we'll do a max. And this is actually going to work very similar to the depth in the way that we calculate it. So we'll put these in here. So what we're going to do is we're going to do a particle size, part size. So part size is going to be essentially the same as this, but we're going to change some values. So min, we want to do min, min, and max, max. So it's going to essentially do the exact same thing. It's going to go within that range, make sure it goes in and out of that, and then adjust the part size. So we actually have to make this apply those. So we have to do emit arms dot start size equals part size. Okay, so let's give this a try and see how it works. Okay, so we are getting, yeah, a big range of different sizes and colors inside here. We might want to play around with these values, but this is kind of a good starting point to see the different things that we can do with a system in a relatively short amount of time. So thanks for watching. If you like it, please subscribe to support.